Greetings, this is Mark Anderson from Kellogg Community College, and today we're going to look at easy trinomial factoring. Now, the reason why they're considered easy is because if you look carefully at all of these examples from 7 through 14, all of these examples have an x squared in front. Because the basic trinomial formula is ax squared plus bx plus c. But in this case, a is equal to 1 in all of these problems. And you will see that actually doing the factoring is going to kind of boil down to a pretty easy trick or pattern. It really deals with FOIL, but it deals with basically just the OIL part of it, or the oil part of the the oil part of the FOIL. So it just deals with the this O and I and the last cable. And we know that the last part gives us this letter C. So we're looking at two numbers to multiply to make C. And the O and I are then added together to make the B term. So really we're looking for two numbers to multiply to make C and add to make B. So that's the pattern. So if we look over here and say, okay, what two numbers multiply to make 8 and add to make 9? Now there are several, there's a couple that actually multiply to make 8, which is 1 and 8, and also 2 and 4. And but only one of these pairs is add to make 9, and that would be 1 and 8. So the factored form would be x plus 1 and then x plus 8. And that would be my factored form for this problem. If I FOILed it to check my answer, I'd have x times x, which is x squared, 8x and 1x making 9x, and then 1 times 8 is 8. So, hey, look at that. There is my FOILed problem. Let's look at, and one last thing I should say is you could write this problem as x plus 8 and x plus 1. It would be okay because it would still FOIL to make this answer. Okay, so problem number 8. What two numbers multiply to make 14 and add to make 9? There's really only one combination that works because to make 14, it could be 1 times 14 or 2 times 7, and 2 times 7 add the 2 and the 7 add to make the 9. So you can see now that the 2 and the 7, this makes the L or the C term, and then adding them together, the 2 plus the 7 make the 9 in the middle. Now you'll notice that these will always be x and x in front because since our a term is 1, the only way to get x squared is to go x and x. So this makes for some pretty fast factoring. So two numbers that multiply to make 12 and add to make 13 would be 12 and 1. Or 1 and 12. Again, you could write this either way because multiplication is commutative. Okay, for this problem, we're going to make things just a little bit more difficult. We are going to look at this 40. Now this 40 here, we need two numbers to multiply to make positive 40 and add to make negative 13. Let me see here. If I take a 1 times 40, that does make 40, but there's no way that adds to make a negative 13 there. Let's go with 2 and 20. Well, 2 and 20, that makes 22, and that's not 13 here. 40 doesn't divide by 3 evenly. Let's try 4. 4 and 10. Let's see, 4 and 10. Nope, 4 and 10 make 14, not 13. Let's try 5. 5 and 8. There we go. 5 and 8 make a positive 13. Oh, man. How would I make a negative 13? Well, by making both of these negative. If I make both of them negative, that means that I would get a negative 13 here and still get a positive 40 up there. So now my answer is x minus 5 and x minus 8. Now if I FOILed that out, I would get a negative 13x in the middle with my O and my I cable, and I would get a positive 40 for my C because that would be negative 5 times negative 8, which makes positive 40. Number 11 is similar to number 10, looking for two numbers to multiply to make positive 16 and add to make negative 8. Well, the options here are pretty limited. So out of all these examples, which one makes the negative 8 in the middle? And it would be this final pair, the negative 4, negative 4. So here's my answer, x minus 4, x minus 4. Now, I do understand that you could rewrite this as x minus 4 quantity squared, but in the next chapter, our rationals chapter, we're going to want to keep these separate so we can do some simplification, or canceling as some would say. Let's look at number 12. Ooh, number 12. It's a little trickier because here I need a negative 28. When I multiply, I need my negative 28. When I add, I need a 3, which means that I have to now consider with my 1 and 28, one of them has to be negative, all right? Is it the 1 or the 28? Well, either way, it's not going to work, so there's a combination that just fails, because 1 and 28, no matter which ones are negative, you're going to get a 27 or a negative 27, not a 3. Okay, so let's try 2 and 14. Again, no matter which one's negative, the 2 or the 14, you'd get a negative or positive 12, so that doesn't work. So let's try 3 and 28. Nope, doesn't divide. So let's go with 4 then. So let's go with 4 and 7, and hey, that works. 4 and 7 works, because if one of these is negative, I can get a 3. Now, which one should be negative? That should be the 4. It should be the 4, because if I had the 4 times the negative 4 times the 7 gives me the negative 28. And then, hey, if I add them together, I get a positive 3. So here it is, x minus 4 and x plus 7. Yep, there it is. All right, so there's my... and again, if you're not sure about these, just FOIL them out and see if they work. Speaking of FOIL them out and see if they work, try this 13. Just pause the video and try it. I mean, if there isn't a trick in this problem, I wouldn't do that to you. Or I totally did that to you, because I think a lot of you are seeing this 5 and going like, oh man, yeah, 5. I can get 5, see, and get a negative 4 by going negative 1 and 4, or negative 1 and 5. See, negative 1 and 5, that totally doesn't work, because negative 1 times 5 makes a negative 5. Yeah, this doesn't work. This is prime. Yeah, you can't get a negative and a positive to make a positive, and then you can't get the 4. I mean, if that was a 6, I'd be totally agreeing with you, a 6 or a negative 6. But no, this is prime, because the whole thing can only be divided by 1 in itself. So, yeah, this is unfactorable, and you may, if you can squeeze out of your professor, like, hey, how many prime problems are there on this test? They shouldn't tell you. I mean, and also, just because you can't find an answer, maybe it's not prime. Especially when we start to learn about imaginary numbers. There could be some imaginary ways. Again, let's leave that for the quadratic formula chapter, shall we? Let's look at problem 14. This one is factorable. It isn't prime. We need a positive 21 here. So what two numbers would make a positive 21? And see the negative, so they both have to be negative. Now, at this moment, you may be tired of writing down all the factors, so just do it in your head. Can you think of two numbers that multiply to make 21 and add to make negative 10? Well, 7 and 3 multiply to make 21, and if you make them both negative, they add to negative 10. So you will find the more you do these simple problems, the faster you'll go, and fortunately, this is probably the most common kind of factoring you're going to be doing in the next chapter, depending on your book, of course. So thank you again for watching the easy, or the trinomials where the first term is a 1. Thank you.